So dear students, today's we are going to discuss the extension theorem. So according to this extension theorem, every linearly independent subset of a finitely generated vector space can be extended to form a basis of this vector space V. The proof of this theorem which we are going to discuss here is not given in any book. So you are requested that to read the proof carefully, and if you find there is some mistake or you are not satisfied with that proof, then please tell me in the comment box. I will be happy for your suggestions. So let's see the proof of this theorem. Proof: let S say V1, V2, VR be any linearly independent set in V. We have taken S be any linearly independent set. Now, to become a basis, we must have two conditions. Number one, either S is maximal Li, either S is maximal linearly independent set, or second one, S spans V. If one of these two conditions are satisfied, then S becomes a basis. So now suppose S spans V. Suppose S spans V, then it is basis. Then it is basis because it is Li also, and our theorem is proved. And theorem is proved. If this set spans V, then it is linearly independent also. So every linearly independent set which spans the vector space V becomes a basis. So it becomes a basis and theorem is proved. So again if if S is maximal Li, if S is maximal Li set, then it also becomes basis because every maximal linearly independent set becomes basis. Then our theorem is proved. If X is maximal linearly independent set, then it is basis because maximal Li set becomes a basis, and our theorem is proved. So now suppose that S is not maximal. Now we suppose that S is not maximal. If S is not maximal, then there exists some VR belongs to V such that this VR plus 1 does not belong to L of S. These conditions will hold because if S is maximal, then every element of this vector space V will belong to linear span of S, then we have nothing to prove. So if S is not maximal, then there exists an element VR plus 1 such that this VR plus 1 does not belong to linear span of S. It means that the set V1, V2, VR and VR plus 1, this set, say S dash, is linearly independent, because we have already proved a theorem that if this some element does not belong to linear span of S, and if we put that element in the set, then the set also becomes linearly independent. Now again, if S dash is maximal, then it becomes basis and theorem is proved. Theorem is proved at this step. Now S dash is not maximal. If S dash is not maximal, then again repeat that process. There must exist some VR plus 2 belongs to V, such that VR plus 2 does not belongs to linear span of S dash. To put that element, then this implies the set, say S double dash, V1, V2, VR plus 1, VR plus 2 is linearly independent. So if S dash is maximal, then theorem is proved at this step. If S dash is not maximal, then we repeat this process. So this process will stop after a finite number of steps. Why? Because V is finitely generated. V is finitely generated vector space. So this process cannot go infinitely. So hence there exists a finite set. T. You can say VR plus 1 and so on, Vn, which is maximal. Li set. You can say this T is the extension of S. So there exists a finite set T which is maximal linearly independent set and hence a basis, and theorem is proved. So every linearly independent set can be extended to form a basis of the vector space V. So this was the proof of this theorem.